Aw, animals.
Are humans next? China successfully cloned monkeys using transferred DNA, marking the first time such a feat has been achieved and possibly paving the way for human cloning. Scientists in Shanghai have cloned 2 genetically identical macaques using the same technique that produced Dolly the sheep. Somatic cell nuclear transfer involves taking the nucleus of a cell, which contains its genetic material, and injecting it into an egg that has had its own nucleus removed. The egg cell is then treated with enzymes to stimulate embryo development, just like a naturally fertilized egg. In all, the researchers created 109 embryos and implanted them into 21 surrogate monkeys, resulting in 6 pregnancies but only 2 live births. The macaques named Zhongzhong and Huahua aren't the first primates to be cloned, though. That distinction belongs to Tetra, a rhesus monkey created using a simpler embryo splitting method. The Chinese team believes the monkey clones could be useful in medical research, specifically in the study of genetic diseases like Parkinson's or autism. Cloning, yay or nay? All in the name of science. A team of scientists has recloned the world's first dog clone in a bid to find out if the process has an impact on a clone's health or lifespan. Dog clone Snuppy was created in 2005 using a stem cell from an Afghan hound and born via a surrogate Labrador mother. The original dog, named Tai, died from cancer when he was 12 years old. Snuppy would later live to age 10 before also succumbing to cancer, though not the same kind. When Snuppy was 5 years old, researchers collected his stem cells while also taking eggs from female dogs and taking out their nuclei. Using a process called somatic cell nuclear transfer, nuclei from stem cells were transferred into the empty eggs, then stimulated into dividing, creating over 94 embryos. The embryos were implanted into surrogates, resulting in the birth of 4 live reclones. Though one died from diarrhea days after birth, the remaining 3 are now 9 months old and still healthy. Researchers say they will closely monitor the puppies and measure virtually all aspects of their lives, including growth, metabolism, immune system, and disease development. Stay tuned.
Human cloning, the cure for diabetes. Scientists in New York announced on Monday that they had used human cloning techniques to create stem cells able to produce insulin, effectively curing diabetes. Type 1 diabetes occurs when the body's immune system destroys insulin-producing beta cells in the pancreas, resulting in insulin deficiency and high blood sugar levels. For the first time, scientists have successfully replaced the damaged DNA of a type 1 diabetes sufferer with the healthy genetic material of an infant donor. The hope is that when these new cells are injected back into the diabetic patient, they will begin to produce insulin. The procedure would prevent the need for daily insulin injections and effectively cure the disease.
Man may never again have to fear losing his best friend. Korean company SHANGHAI Biotech says it can clone dogs, and to prove it, it's holding a competition to give one UK resident the chance to copy a pooch. The cloning process involves first obtaining skin cells from a living dog or one that died within the last 5 days. The DNA-containing nucleus is then extracted from the donor dog's cell. The nucleus of a surrogate egg from another donor is enucleated and fused with the donor nucleus. The fused cell begins to multiply and grow. The fusion process eventually produces a cloned embryo. The embryo is then placed in a surrogate dog, and the clone pup is delivered around 60 days later. SHANGHAI Biotech claims it can clone any breed, size, or shape of dog for around $100,000 per dog. Scientists hope the technique can one day be used to clone specialized rescue dogs or endangered animals.
A group of researchers from Oregon Health and Science University succeeded in using cloning to create human embryonic stem cells, paving the way for development of replacement tissue to treat diseases. The process involved first taking skin cells from a patient with a genetic disease. Next, an unfertilized donor egg was stripped of its DNA. The skin cell was then placed within the cell membrane of the donor egg. Electricity was used to prompt the egg cell to divide and grow into an embryo. Stem cells were then extracted. These can be used to grow muscle, liver, and nerve cells, which can be transplanted into the original patient without risk of rejection. Opponents have called for a ban on the experimentation of human embryos, calling the practice unethical.